Hello everyone, welcome back to VAST.U and to the series where we are exploring ways to create scripts to add details to your architecture model. Now, in today's video, we will learn how to make a script to add detailed buildings to your model in just a few seconds. Now, I get it, the level of details that you want for your building would vary and would change depending on the project that you will be using the script on. So we will be going through three different scripts so that you can get exactly the level of detail in the buildings that you want. So without any delay, let's first have a look at all the three scripts. So the first script is super simple. It lets you generate buildings where you can control the podium height, tower scale, and tower height. All you need is an input is the building's curves. And the best part about it is even if your site has a weird shape, this script will still produce a cleaner tower rather than just offsetting the side border, which can sometimes look odd. I usually use this script when I'm making isometric renders or when I need to fill a large area or in the background region where the buildings wouldn't be so much in focus, but I still need something as a placeholders. So now let's move on to the second building script. So this one is my personal favorite and is covered in the next video, which is it allows you to create detailed buildings and not just visually but parametrically as well. You will have loads of control and settings like different height of ground floor, customizing podium floors with parameters for their number and height, adjusting the tower placement on the podium so that it's not just stuck in the center, adding details like core and floor edges. So that's not all. The output will also gives you details like site area, FSI of the building, ground floor area, and total floor area. And here's the cherry on top. We will also learn to use Galapagos. Essentially, you can input your desired final value like FSI or floor area, and Grasshopper will tweak the parameters for you until it gives you the exact result or the result close to it. So this script is fantastic for urban design and planning proposals as well. Now let's move on to the third script. The last script focuses mainly on the towers, and here's why you shouldn't skip it. This script is perfect for creating towers where every nth floor has a taller floor height. This is a practical requirement when you need service floors after every few levels in tall buildings or towers. You will have parameters to control how much the floor height increases and after how many floors you need, and few other options to customize your tower. Now, the best part about these three scripts is that you can mix and match as per your own convenience and get exactly the building that you are looking for. So let's get started with the first script, and feel free to skip to the other two videos for other scripts. So this is the first script and we will quickly see how to make this. It's very short, it's very simple to create. So let me quickly show you how this works. So I can set multiple curves, as many curves as you would like, and basically the amount of parameters that you will have are these ones. So you can set minimum scale for tower, and this scale is compared to the podium. So you can set maximum scale of the tower, you can set tower height minimum and maximum as per your needs. You can set minimum podium height and maximum podium height. Now you can again change the parameters from here. If you want maximum podium height to be more than what it is right now, you can change it from here again, and then the combination. So let's suppose you want this buildings to be shorter because this has a much higher footprint. So this looks pretty good, but in some cases if you want this building to be a much taller building, so you can try different combinations and just basically set whatever fits your design or how you are envisioning these buildings to be. This looks much more balanced, so this looks pretty good. Now let's quickly see how you can create this from just one curve or multiple curves. So let me just hide this real quick, and let's start with a simple curve here somewhere. Yeah, so just gonna start with a curve, and you wanna set all the curves. So the first thing we are going to make is the minimum and maximum height of the podium. So these two parameters we will be focusing on, these two. So let's quickly start by that. Now for that, what you wanna do is first thing first, basically just extrude it. So let's extrude, and what you wanna do, just keep it a little bit far away, and then in extrusion what you need is the direction, which is the Z direction, of course. So you're going to quickly put the z direction. Now another thing that you need is basically random units or random numbers of height that you might want to put your podium to. So for that we are literally going to use a random component, which would be this one. Now I'm just gonna put random. Now you need the exact number of random components or random digits, which will be equal to the amount of curves here. And how you want to do that is basically put a component which is called list length. So let's just put, and I'll explain to you what it does. Is basically it counts the number of curves you're gonna put here, so that there are no less or no more number of z extrusions in one curve. So let's put the number here, and the range. Now let's put a range. So for a range you need a domain. So right now a domain of this is 0 to 1, which is a bit too less, to be honest. So let's start with a range. Now this range could be construct domain. So let's construct domain. Okay, so basically domain start is the range, the lowest point of the range, and domain end is the highest point of the range. So let's put I don't know, let's put 10,000, and here I guess 25,000. Now I'm making it in millimeters. You can change the same thing into So here you have different sizes of podium, and let's put another. So seed is basically the combinations, it's nothing else. So you can put as many combinations you want, and it will change the combinations according to your number. It doesn't matter, but it will still be in the range of start and start and end. So let's rename it to minimum podium height and maximum podium height. Cool, and we'll just take it far away so that we are not confused. I'm just gonna push this. Again, make sure to keep your script as clean as possible so that you can come back and have a look at it. Now what we want to do is take the seed here. Let's take the seed, and I'll change the name. I'll actually not seed, combinations. Come on, combinations. Okay, so now that you have a podium, let's just quickly make a cap. Cap holes will basically make it as a solid geometry instead of the curve extrusions that you're gonna see now. And I'm just gonna hide the basic extrusions so that we have one clean geometry. Okay, so now that you have a podium where you have two components of minimum and maximum podium height, now the second thing which you will need is basically now a tower scale, or a tower is going to be offset of this curve basically. So let's do one thing, and let's start with tower scale. So I'm just gonna put a scale component here. Now it should be from the center, so the scale should be from center. So we are gonna put an area component which will give us a center of the curve. So now we have points in the center, so the center will be this. Now again, factor here would be again a minimum and maximum factor, which would be tower scale minimum and tower scale maximum. So again we are going to use a range component for that, or actually a random component. And then so basically we are using random so that if we give range from 0 to 1, it will understand that okay, you have to make these 0 to 1, so it will create kind of a hierarchy. We don't need a hierarchy right now, we need randomization. So that's the only reason we are using a random, so that it randomizes and it does not look like okay, so the height is going from lower height to higher height in terms of, you know, from the center to the end of the city or something like that. I mean, if you want that, you can keep that and remove the random and just try it with range. It would honestly be a very different result, but you can try it on your own. And let's put again a domain, so a construct domain. Honestly, this is the only thing that you are going to use continuously in this tutorial, so make sure you remember this. Construct domain, and again the number of the number of random numbers that we need is going to be exactly this. So I'm just going to keep the list length in the middle because we are going to use it multiple times. So, and here the domain start could be, I don't know, so the offset, oh sorry, so the offset, so the minimum would be 0, but I want to put it 0.111 so that we have a kind of more control. Yeah, so the minimum is 0. So let's keep it the minimum to, not sure, 0.5, yeah, and maximum would be 0.8 for now. Cool. Now you can see that we have a scaled geometry. Oh, we haven't put geometry yet, so let's put geometry in there. Cool. Now you can see we have random offsets of different curves. If it does, it looks like it's same, but it's actually not. So I'll just increase the lower end so you can see the difference between them, but normally it should be between 0.3 to 0.8. Actually 0.52, so that it looks a little bit more balanced. Now what we are going to do is basically extrude them. Actually, before extrusion, what we want to do is we want to move these curves or tower curves near to one of the edges of the podium, so that not every tower is on the center of the podium, which will be the real case in the city or in your urban design, that not every tower will be sitting exactly in the center. So what we want to do is pick a random corner in all of these corners of the line and push it to the same side of corner in the other line. Now how we do that, so let's deconstruct the brep. So let's deconstruct brep. Brep is nothing but a geometry. It's just a fancy word that I don't know why they use for. They could have just used geometry, but sure, why not? So this is the brep. Now it gives us face, edges, and vertices. Now we want to pick one random vertices in all of these points. So in case if we are picking this point, we want to push it here so that it's in the one of the corners, or if we are picking this vertices, it should be here. So let's pick that. So I'm just going to pull this down so that we have much more space for us. Okay, and now what we want to do is, the first thing will be list length, but we actually have a list length, so we don't want that. Now the second thing would be to take the vertices and pick any one of them from each of them. So right now, if you see the panel, we have 4 vertices in these geometries, but in the bigger one we would have like 9 vertices in this case. So we want to pick one from each set, and what we want to do is just basically move the geometry to the other vertices of the same curve. So let's do that. So I'm just gonna pick list item. List item helps you to pick any one. So right now the index is 0, which means on all the vertices it will pick the 0 point. Now here it might look random, but in case you have a rectangular city or like a urban plan where everything is almost rectangular, you will think that you will feel that all the buildings are coming to the one corner, and you don't want that. So again, we want to randomize the index point here. So again, we are going to use a random component. Now here the range doesn't matter. We can keep it 0 to 1, or actually let's keep it 0 to, I don't know, you can keep it a random number more than 12, because even if they have more than 4 points, or sorry, less than 12 points on our higher range, it will come back again. So if this is 0 0 1 2 3 4 5 6 7 8, so don't worry about it, about the range. Just keep it as higher as possible. I would keep it to 12. You can keep it to 15, 20, I don't know, 200, I guess. So we are just gonna put the random index here, and now you can see it has started to randomize. But what we need again is to connect the seed and list the exact numbers. So let's do again a list length here. Okay, Oh, actually the list length will be from here, because we want the number of geometries from here. So the list length would be from here. Cool. This is interesting, and we wanna do a craft here. I'm so sorry again, let's keep the list length here by itself. So the reason we are grafting is because we want each random number. So I'll quickly show you. Now you can see there is just one set here. So there is just one set here, but then there are multiple sets of data here. So what we want to do is, actually, sorry, here. So what we want to do is say this should be here. So a number 9 point should be here. Number 4 point should be here. The number 9 point shouldn't be here. So we want to graft each set or each number here with each set. And that's why we are using graft here. So that is done. Now we just have to again, so now this point is selected here. We want to make sure that this curve, the bigger curve or the main curve, also picks the same corner here. So what we want to do is just copy the deconstruct wrap, and we will copy the main curve to the deconstruct wrap, and again just copy the list item vertices with the same. So now you can see we have same corners selected in all the geometry. And what you want to do is make sure the seed is again common. I mean, you can do a different seed, but I usually like it to be a common seed. Doesn't matter to me much, but if you want a different randomization for this specific thing, you can go ahead and do so. Now that we have points, we want to move our geometry from this point to this point, and the geometry that we want to move is the scaled geometry. So I'm just gonna put the scale geometry here, and this point would be, actually this is a wrong move command, so I'm just gonna type again. So move to point would be a better one in this case, because that's what we want to do, move from point A to point B. Just gonna delete this one, and the point A in this case would be this. The point B in this case would be this. Okay, so now what is happening again is that it's moving all the geometry in all the points. So what we want to do is again graft it so that each geometry remains separate. So now you can see it's coming closer to one of the edges of the original geometry, and this looks much more real in terms of tower, that there will be the tower offset would not always be in the middle and would be on one of the corners. Now let's go ahead, and I'm just gonna, so that I'm not confused. Okay, now we want to make sure that, you see, this is a very weird geometry for a tower, and in reality this would not be the case. A tower would be a much cleaner geometry, would be almost a polygon of like 5 or maximum 6 edges. So we want to make sure that happens. So what we want to do is basically we want to deconstruct wrap again, deconstruct wrap, and I'll show you the reason. So this is the moved geometry. Cool. I'm just gonna hide all of this, and what we want to do is rebuild the curve. So we want to rebuild the curve. Now instead of faces, I'll take the edges here, right? And the count here could be, so here the point count is like much bigger, it's almost 9. So you want to make sure that the point count is 4, or you can keep 5, but let's do that. So here what we are gonna do is, actually this would be the, oh, I'm sorry. So let me join this curve first. Cool. So once you join this, it's gonna work better, because right now they are individual edges. We don't want individual edges, we want a joint curve. So make sure you put the joint curve, and now you can see the new curves that are being made are much cleaner in terms of how the geometry would be, especially in this case. You can see it's much cleaner. I mean, it's going a little bit outside of the geometry, but you can change again the combinations here, and you can make sure that everything is inside inside the geometry. So this works much better in terms of the tower, and I'm just gonna again hide this. Now all that is left is to again put a random extrusion value. So instead I'm gonna put extrude. So this is the base, and again the direction will be Z. We are gonna do the same thing. We are gonna put a range, and sorry, first it will be a random, and we are gonna put a construct domain range. And so this will be the minimum height of the tower. So now in this case, let's say the minimum height of a tower would be 60 meters, I guess. I mean, you can take it more, but yeah, I'm just giving an example. And sure, the maximum could be 100. I mean, normally the maximum 100 is too less for a maximum. I'll keep it to, I don't know, 140 meters sounds more realistic. Enter and okay. So I'm just gonna increase this, and here you can see. But now what we want to do, the second step would again be a graph, because we want each one to be separate. So here it is, and the number would be, again the length would be the number, actually not the length but the list length in this case. Don't get confused with this length to the actual length of the curve. It's just the length of the list, so phi basically in this case, because there are phi curves. So here you have random, again the randomization of the heights. Now again I'll put combinations or the seed value here so that we have control. Oh, it changed. That's it. And now what you want to do is probably cap it so that it becomes a solid surface, and that's it. So I'm gonna post the whole script, a properly tagged script with everything in the description. Make sure you download the image or the JPEG. It will be much useful while you are following the script in the video. So that's it for this video. Thanks for watching.